Okay. So in operator overloading, actually, so the compiler knows the definition of existing thing how to do. So for example, we have an operator class. It can perform addition of two numbers or two numbers if it is an integer value or float value, whatever it is. So, but it doesn't know how to add two complex numbers. So then we can write our own definition how to do addition of two numbers. So that means we can overload the actual functionality of the plus. So actually the operator plus actual functionality, it can perform two numbers addition. So, and it is already overloaded. So how it will be, if we put something in this string one, okay, plus string two. If we are given like this, it can concatenate two strings. Correct or not? So based on the existing location, the operator can perform the particular operation. Right. If it is existed in two numbers, it can perform addition of two numbers. It is existed in between the two strings, it can perform concatenation of two strings. Like that, we can provide our own definition also. So that is like, we can implement this one. Okay. How to perform addition of two complex numbers with the operator. Right. Hello. Hello. Gayatri?
Yes, sir.
What happened today?
Sorry, sir.
Anything problem?
Your voice is not properly audible, sir.
Oh. Can you disconnect and connect again?
Okay, let me try.
We can now we'll create one class complex. So in a complex number, we know that actually we have real number, imaginary. Okay. So I'm creating one constructor, public complex, int real, comma, int imaginary. So real is equals to, so we can give like this dot real is equals to real, this dot imaginary is equals to imaginary. Right.
So what is this?
This means, already told you, this represents the current object. Actually, if you see here, it is also real and it is also a real variable. It is also the name of imaginary. This is also name imaginary. Even if you are not given this, automatically it can store the given value into this one. Okay. But if you give this, means automatically the compiler can treat. So, okay, the variable which is created under the class level, okay, global level, we have to store the value into this variable. Like that, the compiler will treat. Understood? Both are same.
Yeah.
So there is a possibility of assigning the same value into the same variable if you are not giving this. So for example, if I then put the C, so there is a possibility. So it is thinking the same value we are storing into the same variable. That's why we have to differentiate the local variable and global variable by using this. This means by using which object you are calling, that object it is having one variable real and one variable imaginary. Correct? Okay. We have to store the values into that variable.
Okay.
Understood?
Yeah, understood.
So we have to give one default constructor also. So here I am not specifying real this because so we have only one variable with the name real and imaginary. That is only global. We don't have any local variable to get ambiguity of the compiler. Okay. And
okay.
So I'm creating like this. So if you want, uh, we can create one method to read. Get, get, set, real and imaginary. Okay. So if you want, we can pass, or otherwise we can read it here. Console dot write line enter real imaginary values. Real is equals to, so into dot parse of console dot read line. So it can read the value. Okay. So
Okay.
imaginary is equals to into dot parse of console dot read line. Okay. So then, so we can img.
You can read both the parts.
Yes.
Okay.
Both the values you can return, or otherwise directly you can assign values to the constructor to create the object. Okay. So we
Okay.
are giving multiple options to the user to set the values, either by using constructor or by calling the method. Okay. So public void and display. So we can format. So we can format the complex number. So with the output statement. So console dot write line. Okay. So here it is. We have to format like this: 0 plus 1 I. Okay. Here 0 is
Okay.
have to print real value. So in a one place we have to print imaginary value. So this is what we have to format and print the complex value. So, and okay, see how we can create a complex number. So first we can create an object like complex C1 is equals to new complex of, initially I'm giving like this 5 comma 4. This is the first complex number I'm giving, right?
Okay.
Creating another complex number C1 C2, okay, is equals to new complex. So we can call the function set real comma imaginary. So this is what. So first complex number it is console dot write line. So complex one. So here it is, and we can call the function console dot write only I'm giving. So just because I want to display that number in the same line. Okay. So then we can call the function C1 dot display. C1 dot display. Okay. So and the same like I want to display the second complex number also.
Okay.
Right. Second complex number C2. C2 dot display. Console dot read line. I want to add two complex numbers. I want to add two complex numbers. So then simply we can write one function public. So it returns.
So in this program till now, where is the overloading?
We haven't implemented till now.
Okay. Okay.
I'm writing the general program structure. So for example, if
Okay.
you have a two complex number, if you want to add, generally we can write like this. Correct or not? Add. Okay. So
Yeah.
pass complex C2. Okay. One complex number we can pass through parameter. Another complex number automatically it can come as calling object. So then we can do like this. So complex res is equals to, so new complex. So we can create like this, and res dot Okay, result dot real value is equals to real plus C2 dot real. Real plus C2 dot real. Okay, res dot imaginary is equals to real plus C2 dot imaginary. So because first value automatically it can come as a calling argument. For example, see here C1 dot add of C2 and it's we given like this. Okay, so then C1 it is coming as calling object, so automatically we can give like this. So real value from the C1, imaginary value from the C1 it will take, and it can add the calling argument value real and imaginary, and it can store the into the result. Okay, so then we
Okay.
can return result, we can return a result. Okay, then so if you want to perform the addition, so we can create complex res is equals to new complex. Okay, so then res is equals to c1 dot add of c2. We have to give like this. If you observe, it is like a function calling only. Okay, so
Okay.
we can directly identify we are adding two complex numbers. It may meaning
Yeah.
of adding the thing something else maybe. Okay, so there is no meaning like that. So then, so we can call that, so result dot display, then the resultant value it will come. Result, right? Result it can display. Now you can compile the compile and execute the program. So operator overloading, start execution. 1 minute. Yeah.
Okay. Yes, sir.
Sorry.
Oh, no problem.
See here it is asking enter real and imaginary values. So I'm giving like 3 and 7. Okay, 5 plus 4 I one value, and 3 plus 7 I is one value. So it can add a real value, real part, and imaginary part. Like this. Okay, so but here we accomplished our target, whatever we want to do, that we have did actually. But here there is no meaning while seeing the code. We are adding two integer, two complex numbers on them. So then we can do one thing. We can overload the operator plus. We have a feature of operator overloading in C#. By using that, we can overload the actual functionality of the operator plus, so that we can change it to add a number, add two complex numbers. Okay, so public. So when you want to overload, we have to give it as a static. It is a static function, and it returns a complex value, because after adding two complex numbers, it can return a complex value only directly.
Okay.
Then we have to give the keyword operator. So which operator you want to overload? Plus. Okay. So what type of arguments you need to pass as parameters to this one? C1, okay, comma, complex C2. And so whatever the code you have written here, that I placed. Okay. So but here it is not a calling argument, because it is a static method. So we cannot we cannot call this function directly with the object. Correct or not? When it is a static function, we cannot call the function with the argument. So directly it can invoke. Understood? So like when you want to add, simply you can put like this. Now, so this is the world when. So now we can change this C1 dot add to C1 plus C2. If you observe here C1 plus C2, anyone see this one? They will think that okay, we are adding two complex numbers, and the result will store into this line. So like how we are doing the two integer values. For example, if we have an integer value, we can do like this int n1 comma n2. So we can say that int r equal to n1 plus n2. Simply we can say that. So here we are adding two integer values. After seeing this code, we come to know we are adding two integer values. Yes.
Okay.
So like that, anyone look about this code, look at this code, they can easily understand we are trying to add two complex numbers. So but how it will invoke? So when you can check under which type the object it is created. Okay, so the object it is created under complex type, so then it can go to the class and it can verify so the function which is overloaded the actual functionality of the place. So when you say this operator, automatically the compiler can override the meaning actual definition of the place. So but it won't overload, it won't overload the complete definition. So it only overloading, so it doesn't override the actual definition. So actual definition of plus it is concatenating of two strings and addition of adding two numbers.
Okay.
So but it doesn't override it. Overloading means it is providing one more functionality to the existing one. It is providing one more functionality. It is adding up the new functionality, that's all. Okay, so then when you provide automatically the C1 will go here, C1, and the
So, sir, simply just when we write C1 plus C2, it will understand.
It won't understand. Without providing this definition, it doesn't understand what it have to do. So for example,
The static part which we have written, public static.
see here, operator cannot be applied, okay, on the complex numbers. So because we don't have the class complex doesn't have a definition how to do addition. This doesn't have definition. So if you place a plus between the two objects, okay, we have to provide what it should do.
Okay.
Form. Understood? Right. C1 will come as a first argument into C1. So C2 will come as a second argument into C2. Okay, now you can run this. So 3 plus 7 I am giving. So see, 5 plus 4, right? Correct?
Okay.
So it is doing the same. So when you see this, that we come to know that okay, we are trying to perform addition of two complex numbers. That is called operator overloading. We are overloading the actual functionality of the
existing.
Yes. Right, overloading. So now next one, runtime polymorphism. So in a runtime polymorphism, we can also call it as a late binding or dynamic binding.
Sir, 1 second, my battery gone low. I'll just get the charger. 1 second. Yes, sir.
Okay. So in a runtime polymorphism, so simply we can say this method overriding. You can call it as also method overriding. Okay. So in a runtime polymorphism, the compiler can bind the definition, actual definition, to the calling location at runtime. So how it will implement? So when we inherit one class to another class, if you want to change the actual definition of the base class method in the derived class, that is called overriding. That is also called as runtime polymorphism. For example, you have a method display, okay, in a base class. In base class, you want to give the same name in a derived class, and also you want to modify the existing functionality. Okay, so you want to override that. It is called as runtime polymorphism. Okay, so in
Okay.
runtime polymorphism, we can simply call it override allows the derived class to define a specific implement. So it provides a new definition for the method which is available in the base class. That is called runtime polymorphism. Okay, so you'll see one example. I'm creating a new project. Runtime polymorphism example. So we can call it as a method of overriding also. Method of overriding. So base class we can simply normal function only I'm writing. Here I'm creating void public void display. Okay. So and console dot write line from base class. Okay. So here I'm creating one more class derived class. So I'm creating the function public void display. Okay. And simply we can say console dot write line from derived. The same method I'm writing here. Okay. So and I'm creating an object for base class. Base class some b1 is equals to new base class. Okay. So b1 dot display we can call. So I want to inherit this base class to derived class. So inherited that.
Okay.
So then I'm creating derived class d1 is equals to new derived class. Okay, d1 dot display. D1 dot display. So console dot just read line. So actually we have a function. See this when you inherited, it is showing like so display a hidden inherited method plus display. Use a new keyword if hiding was. So for example, what it is showing like when you inherited base class to this derived class, the actual definition in this base class it is overriding. Do you want to continue this overriding? This is in hiding the base class function like that it is shown. Okay. So
Okay.
so how to overcome this problem? Wonder how to do that. Okay, I'm changing the runtime. Yes, I'm running this. So from base class it is coming, from derived class it is coming. So when you call this function from the derived class object, okay, so only the derived class function only it is execute. But actually the function it is not. overriding. Only it is calling the function it is available in the derived class directly. It is calling this one. Okay. So then,
Okay.
if when you want to do this kind of thing, so the function which is already available in the base class, if you want to write the same function in the derived class, so first we have to provide virtual keyword,
Okay.
actual keyword in the base class, and we have to provide override keyword in the derived. Okay, then that green color strictly is gone. Now it is purely overriding this. So then if you want to call the base class, then simply you can call base dot display. So when you call like this base dot display, so it can call the function display which is available in the base class. Which is available in the base class. Okay.
Okay.
Now we can accomplish like this. So I'm not writing this one actually. So now this is the thing here. So even if you call this one, okay. So now this can works fine, same as it is. So then, sir, where we implemented this runtime polymorphism? We haven't implemented it till now. Okay. So see here, it is a B1, right? So it is an object for
Okay.
base class. So now
Okay.
I'm going to convert this B1 into derived class object. Okay.
Okay.
Here. So till here, B1 it is an object for base class. Now I am converting this B1 to derived class object by defining B1 equal to new derived class. So now if you call B1, so now it is calling the function which is available in the derived class.
Okay.
Understood. So here in a runtime, we are converting the base class object into derived class. First, the display, the function definition which is available in the base class display, it is binded to B1.
Okay.
When you convert the B1 into derived class, now the function which is available in the derived class display is binded to this one. So the function definition is binded when runtime. Correct or not? So in a runtime, we are converting the base class object into derived class object. Then automatically the functions will be mapped with the derived class functions to that object.
Okay.
Okay. So now you can run this. So it can give the same expected result only. Like I am from derived class, from derived class. This one only it can display. Okay. So we are converting the base class object into derived class object at runtime. But
Okay.
not convert the derived class object into base class. For example, if you created like, so someone will ask like this base class, derived class. So we have an object D1 is equals to new derived class. So I'm trying to convert this D1 into base class object, new base class. So it is not possible because see this. So cannot implicitly convert type runtime polymorphism to sorry, base class type to derived class type. You cannot implicitly convert. Okay, an explicit conversion may exist. It should be a casting function inside your class. Okay, so we cannot convert. Cannot convert the derived class type to base class type. We can convert from base class type to derived class. Here we created the object for base class type that we can convert into derived. It may possible, but that it is not possible. But derived class to base class object will not. Understood, right?
But why the reverse is not possible?
Reverse is not possible. Why? Because already the derived class having the definition of base class. That to base class is main one. We can upgrade the object. We cannot downgrade the object, right?
Okay.
So upgrade means we can upgrade to next version. We cannot downgrade to lower version. So base class it is a lower version.
Okay.
Already that to D1 it is already having a base class features,
Yeah,
right?
yeah. It is derived only, so it will have all the properties.
Yes. So there is that too there is no conversion mechanism to convert the derived class to base.
Okay.
If you want, you can write your explicit parsing method, in a function to convert it.
Hmm.
Okay, clear.
Yes, sir. I'll go through again and explain.
Ah, so that is called that is about polymorphism. Understood, right?
Okay.
So here
Yeah.
we are providing multiple definitions with the same. Okay. So method
Yeah.
overloading, we are giving multiple definitions with the same method name. Okay. In operator overloading, we are overloading the actual functionality of the operator plus. And method
Okay.
overriding in a runtime polymorphism, we are binding a method definition to the object at the runtime. Okay, at the
Yeah.
runtime we are binding. So that is maybe a, overriding the actual function which is available in the class. We are overriding the derived class. Okay, by specifying the
Yeah.
keyword virtual and override. So sometimes they will ask how to do the overriding, method of overriding, how to implement method of overriding. That
Okay.
you can say that we have to put the virtual keyword in the uh, what base class method
Base class and the override in the derived class.
derived class. So or otherwise, okay. So if it doesn't specify the virtual, we cannot override. Right.
Okay.
So we
Got
have
it.
to put the virtual modifier. So public is modifier like that. Virtual is also a modifier. We have to provide the virtual keyword in a base class method, and we have to provide override keyword for the derived class method. Then we can implement
Okay. Got it.
some or method override. Both are same. Anyone ask about runtime polymorphism or anyone ask about method overriding? Okay, both
Okay.
method overriding and runtime polymorphism both are same.
Okay.
Okay. So, that,
Yeah.
so next one, sealed class. So when it is, for example, if you observe here, so a base class it is and a derived class. I'm inheriting that base class to this derived class.
Okay.
Okay. So what is the meaning of this sealed? For example, I given. So yesterday we have done some program. Do you remember that we created a student class and we created one more test class and we are calling those methods from the test class? Do you remember that?
Mm, so can I open the program then I'll remember?
Yeah, that's what I'm checking here. Complex numbers. So somewhere in the inheritance only we did that actually. I think in the first program. See this here. See
Okay. Okay.
actually we created a student class, right? So without
Yeah.
creating, just we are creating an object. So I'm reading read data and display data. These functions I have done. Okay, inside of this I'm calling these functions.
Okay.
So now, so anyone wants to create a student object, they can create a test. But
Okay.
what is the actual mechanism? It is done by the student, not test. Correct or not? Not test. Okay, like this here also,
Okay.
extended student is there. Okay, simply I am inheriting all the features which is created in the student class. We are calling to this extended student. So the
Okay.
someone understand. So maybe all the features which is provided by this, not this one. So the
Okay.
doesn't know the actual background. Okay. So then, so when you want to implement one class, so if you don't want to allow to inherit that class, for example, I
Okay.
wonderful program for biometric recognition and validation and all these things. I have done one code. Okay.
Okay.
It is I make it as one DLL and all these things I have done. So then
Okay.
someone taken my DLL and they are creating some classes, new classes in their project, and simply they are
Okay.
using all the functions which is provided in the DLL. Okay, so then
Okay.
so they can give their own DLL to read the biometric and validating all these things. Then
Okay.
my code will gone. So the new code it is coming, but their background they are using my code only by inheriting
Okay.
all my classes. So
Okay. Okay.
you want to provide some security. If you don't want to allow the people to inherit your code and all, then
Okay. Okay.
simply you can put sealed. Okay. So when you are
Oh.
like this, so sealed class. Now you can see here derived class cannot derive a class select a type base. You cannot derive a class with this base. So when you put the sealed, we cannot give override because now we are allowing to inherit this class. So without inheriting,
Okay.
override. So without overriding, there is no meaning of H4, right? So
Yeah. Yeah. Yeah.
then we won't provide that. Understood. When you provide the
Okay.
sealed key,
Yeah.
that class it is locked. So we can say that that is the final definition. Is the final
Okay.
of that class. So we don't want to allow
Okay.
to inherit that class. That is called this.
Okay. Good.
Okay, we have some more features. Abstract class. So abstract class, when you create the class, it has abstract. So simply how
Okay.
providing seal. So simply we have to provide abstract. Okay, so
Okay.
create it as abstract class. The class may contain some abstract methods and some non-abstract methods.
Okay.
It may contain, but it should contain at least one abstract member.
Okay.
Okay, so then
Yeah.
when you create the class as abstract, you cannot create an object directly to that.
Ah. Okay. Okay. Got
See
it.
this?
I remembered this.
Cannot create an instance for this abstract class. So when you create a class as abstract, it is an abstract class only. We cannot create an object for
Hmm.
it. It can.
It is just like a framework. It will have few
Yes, yes.
things which we can use in derived class, but
Yes,
we
yes.
cannot have its own object.
Yes, yes.
Okay. Got it.
Understood. It may contain some abstract numbers. Abstract numbers may also we can how we are providing like this. Same public. So and void ABS one some test ABS given. Okay, simple like you cannot declare a body. Yes, we cannot declare. We can only go to put something like this. Abstract. We have to give like this. Okay. So in a
Okay.
it doesn't. So then we have to. So for example, if you put here, so the other intelligence it is providing like this implement abstract class. Okay. So if you put
Okay.
automatically it can provide the code how to implement and all. So when you create the method as abstract in the abstract class, we have to override the function by using the override keyword only again.
Okay.
Understood?
Yeah.
So this is what abstract class. Uh, console dot write line ABS override. Simply we are providing that.
Okay.
So, and so we can create an object for the derived class. Derived class D1 is equals to new derived class. Okay, so simply we can call the D1 dot display. We can call the display function which is available in derived class. So we can call D1 dot test abstract method. So we can call it as. So now you can run this. derived class ABS override. Understood?
Okay.
So whatever the
Yeah.
code you want to implement in the latter, okay, where you inherit, that time you can provide this.
Okay.
Okay, how it will be, for example, we have some security classes are woven security in .NET. Okay, so but you can create your own validation ports and all by inheriting that class to your class, and we can provide your own functionalities to validating and all these things. Understood? Like this, what said, we can create like a framework. We can inherit and we can override, and you can provide your own definitions. So like that it is.
Okay.
Okay, we'll stop here tomorrow.